Yeah. They used to, but not anymore.
Yeah, they don't.
It's all changed.
So hard to keep up with.
Alright. Quiet, please. So, I do not have anything new to teach you. But, this is probably going to be the hardest assignment you've had the whole year. Thus far. So, and it's just because Tragan is involved. So, we're still going to find the equation of a line, equation of the normal line, find the derivative, find the slope. But now you got to do trig. So, you guys all wrote those down yesterday, right? What? Oh, yes. Because that helps you memorize them really well when you take photos and things, yeah. So, I mean, for today, I would have that out or look at the board, and, that's perfectly fine. But starting tomorrow, you write down what I'm allowed to do. I am eligible to I'm allowed to give you a pop quiz at any point I want with these things on it. Derivatives of trig e to the x ln of x. I guess I should clarify because I don't know if I already mentioned it yesterday, but that d over dx is just like an abbreviation for derivative. So like the top one says the derivative of sine of x is cosine of x. Right? I think you probably picked that up, but just clarify. Otherwise I have to write like y equals sine of x, y prime equals cosine of x. It just becomes twice as much writing. So just shorthand. Derivative of cosine is negative sine. Remember we talked about yesterday, if it starts with a c, your derivative is negative. That's a little bit of a helpful clue. But at any point, starting tomorrow, and I wouldn't ask you to calculate anything with these. It would just be like, number 1, what's the derivative of sine? Number 2, what's the derivative of secant? Number 3, what's the derivative of dx? Number 4, what's the derivative of cotangent? Also eligible is any unit circle questions. So what's the cotangent of 2 pi over 3? What's secant of 225? Things like that. Also eligible is any log, natural log type questions. So the power stuff we were doing. Also eligible is things like, 8 to the negative 2/3, 16 to the 3/4, solve x to the 2/3 equals 25, stuff like that. So this is like the pre-calc review stuff that we did, right? Again, we talked about that doesn't go away. So I'm going to try to kind of hammer it into you. And then this is the new stuff. So notice there's no calculus in there. I'm not giving you a pop quiz on calculus. I'm giving you a pop quiz on, I'm eligible to give you a pop quiz. I'm not saying I'm going to do it. On the pre-calc stuff that we talked about and straight up memorization. This drives me crazy. People will come back to me and say something like, I didn't understand that. I didn't understand the derivatives. That is complete garbage. Don't tell me you didn't understand that. There's nothing to understand. It's did you decide to memorize it or did you not? I'm not saying anyone is going to use that excuse, but if I said to you, I'll give you $10 million if you memorize those tomorrow, you'd figure out a way to understand it. You know what I'm saying? There's no understanding. Yes. Yes. You want to take a picture of that? Go for it. I thought you were going to fight me about my memorization comment. I was ready to rumble. I'll turn the lights on even. Photo time. Shield, you have a question?
I did, but I forgot it.
Rambled on for too long.
I don't even know if it was that.
So, usually... Hold on. I'll tell you straight up, I'm not going to do it tomorrow. Whether or not I give one kind of depends on whether I think you guys are putting in an effort to memorize them. So, if I come in tomorrow and I start going through problems, I'm like, hey, what's the derivative of sine? Everyone just stares at me. And I'm like, okay, you assholes need a quiz.
Oh,
I'll give you a quiz.
Whoa!
But if I'm getting like, hey, what's the derivative of secant? And everyone's like on it, I have no reason to give a quiz. And I usually will give you some sort of warning, like a hint, like, hey, you might want to be ready for this. So I'm not trying to give you a pop quiz like out of nowhere. I'm not trying to hurt your grades. I'm trying to make sure you know this stuff. So there won't be one tomorrow. That's myself here. So yes, it's technically not a pop quiz, I guess, but do you want a pop quiz? I'm trying to be nice. I'm trying to argue with my wording. Yeah. Did you remember your question now?
Yeah. It's about those.
Yeah.
So for example, the first one, the derivative of sine x is cosine x.
Yep.
Could it be the derivative of negative sine x equals negative cosine x?
Yeah, so we'll start talking about that with these. Any constant that is in front of, so let's do that now because you just brought it up. Any constant that's in front of any of those drops right down to the derivative. So, like, the derivative of e to the x is e to the x. We can talk about why this is, blah, blah, blah. This one's pretty, I think that's cool. But if I said, what's the derivative of 5e to the x, it would be 5e to the x. If I said, what's the derivative of 5 secant of x, it would be 5 secant tan of x. So any constant in front just drops. We'll talk about why in like a week or two, but for now, just memorize that. What's the derivative of 4 cotangent of x? Negative 4 cosecant squared of x, right? Fair enough? That's what you're asking.
Yeah.
That makes sense?
Yeah.
Alright, so let's look at it like the first one here. Again, there's nothing new on here. It's just practicing the trig mostly. Like this. Okay. So that comes up right away. You got the negative 2 in front of the tan. So I want to find the derivative of the function at the given value. So what are my steps? Like forget tangent, plugging in, all that. I mean, forget the derivative. What if I say find the derivative at a given value? What are your 2 things that you're doing? First step, take the derivative. Second step, plug in x to where? Okay, we're not going to say it, right? We plug in the x value to the derivative. Plug in the x value to the derivative. So the derivative here, the negative 2 just drops. So it just falls down in front. The derivative of tan is secant squared. And you can write that as that squared above the sec before the x means you're squaring like the whole thing. So those are the same. You can write it either way that you want. Usually the calculus, the AP test will write it without the parentheses, but you can put them in there if it helps you. And then my job is to plug in negative 5 pi over 6. Well, negative 5 pi over 6 is negative 5 times 180 over 6. So remember we talked about, like, do the division first. So 180 divided by 6 is 30. 30 times 5 is 150. So this is negative 150. So you can think about going backwards 150 on your unit circle, or you could add 360 to that and think about it as going forwards 210 degrees. Either way, you get to this like lower left-hand quadrant. You would be 1 tick mark down and 3 tick marks to the left. So now the trig part's the hard part. Secant is which flipped over. Secant is the flipped over version of cosine. Cosine's x value or y value? X. So if I'm 3 tick marks to the left, the cosine's negative square root of 3 over 2, right? But I want to flip it. So 2 over the square root of 3. That I think is the hard part. Getting this number right here, I think is the hard part. Should I go over that again? Okay. So secant is the flipped over version of cos. Cos is the x value. So I want to find the x value at that spot and flip it upside down to get to c. So the x value is 1, 2, 3 tick marks to the left because this is 210. So that's going to be the negative square root of 3 over 2. But I want c, so I flip it upside down. Now if I square that, the negative square just goes away, right? So that doesn't really even matter if it's negative or not in this situation. What's 2 squared? 4. What's the square root of 3 squared? 3. And this will be negative 8/3. This is like negative 2 over 1 times 4 over 3. Questions on that one? Like, that process makes sense, right? It's just not easy. Is that fair? Is that kind of where we're at? Let's do one of the tangent line ones. Or normal line, whichever. Let's do number 3. So find the equation of the line normal. So as soon as I see find the equation of the line, I'm bringing this to the party. And then what goes here? X value, which in this case is 0. What goes here? Y value, which in this case is 2. If they didn't give you the Y value, how would you find the Y value? Don't say the word it. Plug the X value into the original. Yes, good. And then what goes here is your slope, right? So how do I find slope? Just like I just did number 1. I take the derivative, plug the X value into it. Should I give you a second to try that before I do it? Or should I just do it? Okay. So the derivative of sec is sec tan. And that constant just falls. So 2 sec x tan x. The constant does not fall twice, because then it'd be a 4. Like, don't put a 2 in both spots. And I want to plug in 0. So I want 2 times the secant of 0 times the tangent of 0. So 0 degrees is over there. What are the coordinates here where at 0 degrees? 1, 0. So then think through what these mean. Secant is what flipped upside down? It's cosine. Yeah, so in cosine's x, right? So we're basically going to do 1 over the x value.
But if it's, oh wait,
X is 1. Yeah. So what's 1 flipped upside down? 1. And then tangent is the y value divided by the x value. Right? So what's that in this situation? 0. Which makes your life a lot easier because what's the derivative now? It's 0. But be careful. Am I putting 0 here? I'm glad we did this. This might be the toughest one on here. So y prime equals 0. That's the slope of the tangent line. But they're asking me for the equation of the normal line. So the tangent line is a slope of 0, which is what kind of line? Don't say straight. Horizontal. What? Horizontal. So the normal line to that is going to be what kind of line? Perpendicular to that would be vertical, right? Think about it with the numbers too. If you take 0 and flip it upside down, don't you get a 0 on the bottom of your slope? Which means undefined. And doesn't the vertical line have a slope that's undefined? So that makes sense. So then what's the equation of a vertical line? X equals some number, and you just choose the x value that is in the problem that we are working with. It's this guy right here. That was a lot of thinking through steps. Are we do it again? Yeah? Armstrong, what's up? You're staring at me like you...
I don't know what I got lost.
You got lost somewhere, but you don't know where?
Yeah.
Okay, so I'll just do it again. Are we okay up to the derivative is 0? Is that part okay? Or did you get lost before that? That part's okay. Alright, if the derivative is 0, then, so that means the slope of the tangent line is 0. That means, I'll kind of write out the thought process. Tangent line is horizontal. But I'm not asked for the tangent line, I'm asked for the normal line. That means the normal line is vertical. You can think through that with numbers too. So if the slope of the tangent line is 0, how do we get to the normal slope? We flip it over and change the sign, right? So if you flip that over and change the sign, you'd have 0 on the bottom. And then that means undefined. And what kind of line has a slope that's undefined? A vertical line. So you can get to this vertical part kind of two ways. And then once you know it's vertical, what's the equation of any vertical line? Is x equals something. And what's the only x value that we have in this problem? It's just from there. It's not because of this zero. It's from this zero. Does that help?
Yeah. My question, why did we use the coordinate 1? Where did that?
0 degrees. So like secant of 0.
So we're just using, okay.
So 0 degrees puts me here, and then this is like my unit circle. So that's not, like this point is totally separate from this point. I was using this to find out what cosine, secant, all that stuff was. You're not like nodding your head, you're just like staring at me, so now I don't know what to do.
It's fine, just keep.
So when you plug in x to the trig, it's no longer like the cosine of something, it's just a degree on the unit circle that you're looking for.
Say that again.
Okay, so when you plug in x to like the trig, it's no longer like the x value of a point, or it's no longer the cosine of something, it's a degree on the unit circle that you have to go. And then so
Yeah. Let's do more. I want to save some for you to do without me. But let me, yeah, there's 4 of them, so yeah. Let's do like 11. Let's do 11. So I'll leave you 2 to do by yourself. That's
yeah.
good enough, I think. Do you want me to give you a chance to try it first, or do you want me to just go ahead?
Give us a chance to try.
All right.
Oh,
luck.
fine. Never mind, just do it.
No.
May the odds be ever in your favor.
Are you allowed to have like pi over 2 in your equation?
Yes.
Okay. I think I did it. But I think the answer is I got it.
We don't really need you to like live tweet your thought process.
Wait, were we doing 10 or 11?
It's not working.
Oh, one on the board with a circle around it.
Well, I definitely got 10 right.
Great.
That's all.
Alright. So as soon as I see equation of a line, starting off with this, then kind of filling in around it, filling in those blanks. So the x value is pi over 2, the y value is 0. If they didn't give you the y value, you can get it by plugging the x value into the original. We can get that. And then I'm going to find find the slope, I want to find the derivative and then plug in the x value. So your derivative is the derivative of cosine is negative sign, so I'm going to throw the negative out in front and make it negative 2 sine of x. Okay? Now plug in. So negative 2 times sine of pi over 2. Well, pi over 2 is how many degrees? 90. So that puts me up. Yeah, what's up?
Cosine x negative sine.
Okay, cosine is not negative sine x.
Or
The derivative of cosine is negative sine x.
Yeah.
So the cosine became negative sine and the 2 just dropped.
Oh,
I just put the negative in front.
okay. Put the negative front. Okay.
So pi over 2 is 90. Sine of 90 is what? That's the y value up at the top of the circle, so that's 1. So this is negative 2. But that's the equation, or that's the slope of the tangent line, right? So what's the slope of the normal line? Positive 1 over 2. And that's typically an acceptable answer. In this case, they say put it in slope-intercept form, so I'll do that in a second. But how many got to here? Questions I'm getting to there? So to put it in slope-intercept form, just distribute. So 1/2 times x would be 1/2 x. And 1 times pi on top is pi, and 2 times 2 on the bottom is 4. And then plus 0 doesn't really move the needle. How many had that? Fourth, what's up?
Why do we have to flip the negative 2? Why can't we leave it as a negative slope?
We're doing it because it says the normal line.
Okay.
So that's perpendicular. If it's a tangent line, we would use the negative 2. When it says normal line, that means perpendicular, and that's when we flip and change.
Okay.
Is that good?
Yeah.
Okay. Should we keep going with me, or do you want to go?
Let's just do it. We've got you for the question.
What'd you say, Cece? Okay. Keep going. Yeah, if you're stuck, then let me know.
Yeah.
I can do them up here. I can come over to your desk.
We're
Whatever.
all working different spaces.
We're all different, man.
Surprising.
Cece doesn't want to talk to any of us. Yeah, so you slow me down. Right. But now it's all right.
Understand.
One on zero.
That doesn't make sense. 6? Yes.
Yeah.
Number 6, the answer doesn't make any sense. It should be undefined. Yeah. Eat my snacks all day. Yeah.
Just little things. Just keep all excited.
Number 6, the answer key is incorrect. The answer should be undefined for number 6.
Yeah, that's not it.
So number 7, isn't that where it says it should be, the answer should be negative 3? And I got, because
It's a negative.
either the negative 1 or the negative 1.
Is it actually?
Like, this isn't even my work. I make mistakes. This is supposed to be.
It's supposed to be like the actual.
Yeah.
Yeah.
That. E to the negative. I feel like college students. Yeah, college students do these, and they're like, yeah, I don't care about high school students.
It's negative 1 over 8.
okay, so that was right.
Yeah.
So was there one? Okay, I don't know.
Are you guys freaking done with it already?
15 was the.
There's another one that's.
That was the last one I wasn't sure because it should just be E, right?
Just either first. Yeah.
And this one, it says it's 1 over E.
Did you do the whole thing already? Yeah. Did you find any other ones? Just those 3? Okay. Man, that's weird. Alright, so there's 3 mistakes on here, which is bizarre. Like, I didn't do these. I'm not saying it's not my fault. I could have checked the answers, I suppose, but I expect the computer to get them right. But you're right. It's just probably like a grad student doing it, and they're like, oh, whatever.
Yeah.
Change those 3 answers. 6, 7, and 15, the answers are all incorrect on there. So these are the correct answers. Stupid grad student.
They're just doing it at like night and they don't care. at all.
Yeah. Why does it have to be at night? You think they care less at night?
Yeah, I don't think people do stuff during the day. They're like, let's just wait.
Cosecant is one. Wait, secant and cosine. Cosecant time is. But it's the end of your question.
Yeah, so you have to. So look up here the way I wrote it. You put the negative inside and it goes away, right? When you're doing, that's an important thing to talk about. Oh, the derivative of cotan is this negative cosecant squared, right? Do not put the negative, inside the parentheses, because if you do, and you square it, it's going to go away. So it's got to be out in front like this, meaning we do the exponent first and then the multiplication, or outside of the parentheses if you want. But you can't put the negative in the parentheses, because then it magnifies will not be there. Yeah, that's easy. Like if there's a constant there, put the negative in front of the constant, it makes the most sense. So then you make positive. Positize it. Yeah. Sorry, you don't know that word. Sounds kind of advanced. Positize.
Alright.